Hey guys, Lucas here and welcome to
Coding with K.
Today I want to develop a little n-body simulation. N-body stands for any number of objects that are simulated together. In this case it's a gravity simulation. So the goal is to display some two-dimensional spheres on screen which fly around each other, bound by gravity. But let me first give you a quick introduction to the IDE, the Integrated Development Environment, which is TIKO. TIKO is an open source editor for the language FreeBASIC, which is of course a more modern version of BASIC. I think it was originally developed by Microsoft, but I'm not sure. At least I know it from Windows 95 back in the day. Anyways, the neat part about BASIC becomes obvious once we start using it. So let's print something on screen, which is hello Kerbin. I press F5 and a window opened and closed. That's because nothing is telling the program yet to stay open. And that command is simply sleep. Try again. There it is, our console window. This console window here can only display text, however. It is useful for many applications, but in this case we want to display spheres and gravity, so we need something more. And this is the neat part about BASIC. All we have to do is to switch to a GUI, a graphics user interface. Now we can use the command screen res, which of course stands for screen resolution. And in here we can type our screen resolution followed by the color depth, which is 24-bit. That's your regular 65,000 colors, I believe. And 24-bit are your regular RGB colors with 256 ranging from 0 to 255 for each color. Okay, let's press F5 again. Boom. And that opens another window. It's not a console window, it's a graphics window. I hope you can tell by the looks. Okay, let's make it maybe a little bigger, 800 by 600. Like so. Try again. And why does it open to the right? I guess we have to live with it for now. But before we get into graphics, I want to highlight one more important thing, which is F1 or the manual. Pressing F1 on any keyword opens the manual, which is fairly bright. But in here we can read up on every command. So screen res initializes a graphics mode by specifying horizontal and vertical resolution. Nice. In here we can see what values we can type in, and somewhere at the bottom we usually also get examples. So you can learn to code using FreeBASIC without even the internet. And the reason of course is it was developed before the internet, literally. So where are the graphics? The most simple form of graphics is of course a pixel, and we can set a pixel with the pset command. In here it expects a location or position, and I will just use the center of the screen, which is 800 by 2 and 600 divided by 2. And next it expects a color, and the color has to be an RGB code like so, and I'll just use white. Okay, now in case you wonder how do I know that, well of course you can study programs other people write or simply check the manual. In this case it found multiple topics, so I just pick one. In here plots a single pixel, target, step and color. And of course the example. Now had we used a lower color depth than 24 bits, we could actually use single numbers. Okay, let me hit F5 again. There we go. There's a white pixel in the center of the screen. I'm not quite sure if you can see it on YouTube. So I will generate a couple more using a loop. In this case, a for loop. For, now I have to create a new value which iterates from 0 to whatever number of pixels I want. In this case, for I as an integer, and that equals 0 to, let's do 1000 pixels. Why not? And the for loop ends with a next command. So we don't use curly braces like in other languages. We just end our commands using other commands. Okay, now we have a variable I that loops from 0 to 1000. So why not use that I as well? We can, for example, manipulate the red value of our color, I times 255, but because I ranges from 0 to 1000, I have to actually divide it by 1000 so that it goes from 0 to 1. And 0 to 1 times 255 is something between 0 and 255. I hope that's correct. But let's just give it a spin. So we should, wait. Instead of the color, we have to manipulate the location, of course, because otherwise we produce 1000 pixels on the same spot, which doesn't make any sense. Let me create two other variables. Dim as integer. This is just how you create new variables. Dim stands for dimension, I believe, but I'm not quite sure. So we need two new integers, x and epsilon. And these x and epsilon values are our coordinates for the pixels. And each one will get a random number. And the keyword for random is RND. And this RND stands for a random number between 0 and 1. So it's a floating point, not an integer. But for pixels we need integers, so we have to convert it to an integer. And that is simply done by int. And in here we multiply it by our screen resolution on the x-axis, which is 800. And here we do the same. RND times 600, like so. Let me think about it for a second. I think it's right. We get a random position from 0 to 800, 0 to 600. Yeah, that sounds about right. And we will generate white pixels. Okay, let's hit F5. Et voila. Hello Kerbin, and we have a star sky. How cool is that? One more thing we can do now, and which we will need anyways, is another loop to generate it again and again, a noise pattern. And for that we use the while. And while ends using wend. Like so. And the while loop will run, well, until we hit escape. And that is done by in key. In key is the key we press, or stores the key value we press. It's an internal variable. So while in key is not equal to escape. And escape is a code. It's a character 27. Oh yeah, this is the not equals sign in FreeBASIC. And how do I know that the character 27 is escape? Well, being an IDE, it also ships with an ASCII chart. Opening that up, we can see all the available keys or characters. A through Z, and on the left, checking position 27 is escape. This is how you can find all the keys you can look for. I of course know 27 by heart because I use it quite often. But let's give this a try now. So it should produce a quite rapidly changing noise pattern. Okay, it's only white. Why is it white? Ah, yes, of course. We generate noise and more noise and more noise. We don't ever delete the noise. So we have to add a command which starts fresh, and that is clear screen or CLS. That will clear the screen every time we create a new noise pattern. Now it should work. There we go. I'm not sure if you can see it on video, but the clear screen command caused it to flash a little bit. It takes a little while for the screen to get cleared and repainted. So another important command, especially for graphics, is, oh wait, let's tap this one more, okay, is screen lock. Screen lock locks the screen, which means it pauses the graphics. Then it clears the screen without actually displaying it. It creates new pixels without displaying it until we screen unlock. Boom. The screen will change all at once, and that is much quicker. Let's try it again. Now again, I'm not sure if you can see this on video, but there is no more flicker. However, it is a little choppy, it stutters. Why is that? Well, that's because we overwhelm the program. The while loop runs as fast as our CPU runs. And our CPU is much faster than the window to generate new images. So what we have to do is to slow this loop a little down. And this is again done by our trusty sleep command. But this time we want to add a little timer. And that is 16 milliseconds. Why 16? Well, 16 milliseconds equals 60 FPS. It's basically 1000 milliseconds, which is a second, divided by 60. And in the end, a 1. What 1 stands for, we can simply read up again in the manual. And that is sleep amount and key flag. And key flag is an optional key flag. Give it a value of 0 for a normal sleep, or 1 to specify that the wait cannot be interrupted by a key press. Interesting. It just means pressing buttons won't make the screen stutter. It's more important later on, just so you know. So let's save and try it again. F5. I hope you can see that it's much less stuttery now. Buttery smooth. We can even, pressing escape leaves the program. And yeah, we can delete this sleep now. And for good practice, we should always end a program with the end command. This just returns letting the computer know everything went smoothly and there was no error. Otherwise, it could in theory generate a crash log or something. I'm not sure. Let's try it again. Okay, hitting escape. Boom. Perfect. But of course, in this video, we don't want to generate noise. So I delete this part here. Update graphics. In here. Okay. And to generate our little spheres, we need another command. Not pixel, but a circle. And the circle again has a location. This time I use one in the center again. Followed by the location is the size. Let's just do 50 pixels. And then I believe is the color is, oh, I have to check up F1. So it's X epsilon, radius, color. Okay. RGB. Like so. Let's check it. Boom. There we have our circle. Now, of course, a planet is not just a circle, it is a sphere, so it is a filled circle, so to speak. And to fill it, we have to add a bunch of commas and an F, I believe. Now, why is that? Because there are more commands like start and aspect ratio. And at the very end is the F, and the F is fill mode indicator. So if we add the F after 1, 2, 3, 4 commas, it should fill the circle, and it did. That's how simple it is. Now all we have to do is to move the circle around. And that is of course done by changing the coordinates here. So x is some number. Let me write that separately. Like so. Okay, we didn't change anything, just make it more readable. And 50 is also a little too big for planets. I'll keep it at 4. Oh, let's do 5. Check it again really quick. Yeah, I think that's okay. But one circle is of course not enough. We need a second one. And that circle gets its own gets its own values. Let me copy and paste this like so, and we will shift it by 200 on the x-axis. Let's try it again. Oh, we have an error, and that error is variable not declared, of course. Now it should work. There we go. We have created two little planets and they are static on screen. They don't move. Now just for show, let's move them without physics. And for that I will use a simple sinus function. On the epsilon axis, like so. And that's of course not enough because the sinus ranges from -1 to 1, which would mean our circle would move by 1 pixel, which is way too little. So we have to multiply it by whatever value we want to shift it up and down, which is 200. And we need a variable which changes over time in here, and that will be our t. But t this time is not an integer, it is a double, a floating point variable of 64-bit size. Let's just call it t. And we need a second one, which is dt, which is the time by which we shift t every cycle of the loop. Okay, the t comes in here, like so, and let's start at 0 and 0. Maybe that's more readable. Okay, and in the end, we will update the physics, and time belongs to the physics, of course. So our t is equal to t plus dt. So we will start at 0, and every loop we will add 0.01 to it. So now the sinus, we can actually remove that part here. The sinus will now go up and down by 1, between -1 and 1. Multiplied by 200, it will range from -200 to 200. So our circle should move up and down as well. And to give them, and you know what? Let's do cosinus on the epsilon 2. So the circles should now move up and down in opposite directions. Let's try it, F5. What is happening? Let me check again what's going on here. Ah yes, of course, this should be an epsilon 1. But I'm still not sure why it went up so much. Let's reduce this to 20. Just to make sure we don't shoot across the screen. Okay. Ah yeah, of course. 0 in this case is not the center, it's on top of the screen, so it's the first line. So we have to simply add 600 divided by 2 to get to this, to start at the center. Like so. This should fix it. Let's try it again. Yes. but that's a little too slow for my taste. So let's multiply this frequency here by 10. It should go much more rapidly now, yes. Up and down they go. But of course, this has nothing to do with gravity yet. All I wanted to show is how to animate circles on screen before we will go on with an actual simulation. Now I think this was enough input for a single video. Before I go on with the simulation, I want you to actually try it yourself. Maybe experiment with more circles and other things. Okay, that's it for this video. Auf Wiedersehen and thank you for watching.